there, we're going to talk about the properties of gases today. So I don't know if you remember the whole Deflategate thing with Tom Brady, and he wanted his footballs to be underinflated so that he could get better ball handling. So gases can be an important thing and affect games. So we're going to talk about the properties of gases in this one. So why are gases easier to compress, push together than solids or liquids? Why do you think that is? That's called compressibility. So compressibility is how much volume can decrease under pressure. So it's super important in an airbag that there's a chemical reaction that happens very fast and it makes a gas. And it makes it so fast, and then your body hits into that big, giant balloon of gas to absorb the energy. So compressibility is really important in this field. So gases are easily compressed because there's much more space in between the particles than there are in a liquid or a solid. And that distance, the greater the distance, the more that you can compress those gas particles together. When you have pressure, like you squeeze a balloon, particles in the gas are being pushed closer together. At room temperature, gas particles have about 10 times more space than the diameter of the particle. So they're about 10 times distance away from each other. So we're trying to do physical distancing now. We're supposed to do 6 feet. Well, imagine 10 times your diameter apart from somebody else. That's the way gas particles are. They're distant from each other. What are the 3 factors that affect gas pressure? So the amount of gas you have, so that's what Tom Brady did. He had less amount of gas in his football so they could handle the ball better. Because the volume of the football does not change, and the temperature that he's playing the game at is not what we're not changing. We can't change that part. The only thing that Tom Brady could affect was the amount of gas in the football. So we use 4 variables that describe gas. We talk about the pressure of the gas, how much particles are hitting the side of the football, and how forcefully they're hitting. That's pressure, and we measure it in those different units. We talked about kilopascals, ATM, millimeters of mercury. We can look at the volume. That's how much size that gas takes up. So that's the size of the football. The temperature we're playing at. So we're going to always do everything in Kelvin, remember, instead of Celsius when we do gases, because it makes the math work out correctly. And then how many moles. So that's what Tom Brady was affecting in Deflategate, is how much gas did he actually have put into the football. So those are the 4 variables we're going to use when we do gas law mathematics. You can use kinetic theory to predict and explain how gases will respond to a change in conditions. If you inflate an air raft, the pressure inside the raft will increase, because you can't change the volume of that plastic air raft. You can only affect how much gas you throw in there. So the collisions of the particles inside the walls of the raft are causing the pressure. If you put more particles inside that raft, you're going to have increased number of collisions of the side walls, and so you're going to increase the gas pressure. So if the gas pressure increases too much, you can actually burst the container. So if you overinflate a balloon, it's going to pop. Any container, even if it's steel or metal, even the earth. So, for example, if you have water underground water reservoirs, and lava hits it, that liquid will change into gas so fast that you can blow up the earth, into a volcano. So gas pressure can be very, very extreme. So we can have gases at 100 kilopascals. We can pump it up with more gas inside there, and we can increase the pressure. And we can increase the pressure so much that we can burst the container. So even big giant tankers that you see trains pulling, if you heat those up, if they have a gas inside of them, if you heat them too much, you can even burst that big giant tanker on a train. So gas pressures can be really extreme, and they could do a lot of damage. So this is how an aerosol paint sprayer works. You push the button. The push button opens the valve and allows this. We have pressure, higher pressure than normal. That's around us pushing on us now. We have lots of pressure inside here of a gas, and it's pushing on that liquid paint. The paint is forced up through the tube, and then you open the valve and it sprays out in a fine spray. So we're doing this in our lungs as well. We're changing the pressure that we're pushing down on our lungs, and then it expels air out of our lungs. So changes in gas pressure can do a lot of good work. You can raise the pressure if you reduce the volume. So if you can change or reduce the volume, you can make the gas pressure higher inside the container. When you change the volume in half, you're going to double the gas pressure. So it's related that way. So if you start with 1 liter volume and go in half, it's going to increase the pressure. It's going to double it. So they're inversely related like that. So increase one, decrease the other, increase the other, decrease the other one. So they're inversely related. Temperature will also increase the pressure. So volume will change the pressure, temperature will change the pressure. If you heat the gas, you're going to increase the average kinetic energy, and the gas particles are going to move faster and hit the walls of the container with more energy, which causes increased pressure. When the Kelvin temperature, remember we have to be in Kelvin, when that doubles, the pressure of the gas doubles, so it's directly related to each other. So if I have 300 degrees K, I'm going to have 100 kilopascals. If I go to 600, I'm going to double it into 200 kilopascals. If I go too high, I'm going to break the container. So let's see how much you learned about gases. So compared to liquids and compared to liquids and solids, if I talk slower, gases are easily compressed because the particles in a gas, why is that? Are spaced relatively far apart, so they're 10 times their size, so you can actually squeeze those closer together before they touch each other. Gas pressure is affected by, we said, quite a few things. What are they? So it's going to be temperature, volume, and the amount of gas will affect the pressure. And so what are the units that we use in this math? Do you remember? We have to make sure we use Kelvin, so make sure that we're always in Kelvin when we do this math. Alright, I hope you learned quite a bit from this, and I will talk to you soon. Bye-bye!